test. It's a Mann-Whitney test demonstration using Aqa S3 June 2013 paper question 3. So let's work through the question and see what it's asking us. Car manufacturer investigates a new device to see whether it would reduce CO2 emissions. For this investigation, 12 new mid-sized cars, each with an engine capacity of 1.4 litres, were obtained, and 6 of these were fitted with the new device. The other 6 were not fitted with the new device. CO2 emissions from each car were measured and results given below. So that's our test data. Now let's have a look at what they're asking us to do in terms of a test. Carry out a distribution-free test. It's what it says in the final paragraph. First step here, as it's in an exam and it's got to be a unique test, we've only got a choice at this point between Mann-Whitney and Kruskal-Wallis. As there are 2 and only 2 lines of data here, it's got to be Mann-Whitney. So in terms of an exam question, we know immediately we're in Mann-Whitney. Of course, in the real world, you just need to check that this isn't paired data, but as there's nothing written along the top here to say it's A, B, C, D or 1, 2, 3, 4, it's definitely not. So as it's 2 lines of data, 2 lines of same data, we know we're Mann-Whitney. Now, on a 5% significance level, to investigate whether there's a reduction in the average CO2 for cars fitted with the new device. Okay, so that really helps because that's basically getting us to where we need to be in terms of determining our tests. So let's do the first. Well, the first thing we're doing in a hypothesis test is H0, the null hypothesis. And Mann-Whitney and Kruskal, we're starting from the premise that both samples here and this one, both samples from same population. Okay, so therefore that allows us to do all the calculations we need, all the calculations to demonstrate that they are the same. Excuse me. Let's just put us back. I'll just end the page. Okay, so what's H1 going to be? As in, now we've got 2 samples to compare and we've got several choices. And as with a lot of tests, you could have either does not equal, in which case we've got a 2-tail test. They're not from the same population, or we can look as in here, where they're actually asking us whether it's a greater than or less than, in which case we're going to have a 1-tail test. So let's have a look here. So that the test they're setting us is whether the emission levels with the new device are less than emissions with no device. Yep. So that gets us going, doesn't it? So we know now we're looking at a 1-tail test. Okay, Mann-Whitney. We have got a set of tables that are going to help us in a minute. And those tables will show us that we're starting off, we're creating a test statistic. So our next step is we're going to create our test statistic. And our test statistic is going to be in the form of U, test statistic, but we're going to calculate that by first getting our t values. We know how that, so we're going to do our rankings. Yeah, and that's what if we look at the tables in a minute, we'll get those definitions. We could check it. So as they're from the same distribution, we're going to go through and we're going to rank all of the data in one ranking. It doesn't matter if it's in the first one or the second, they're treating them as all being in the same distribution. So let's start by looking for the lowest value in this distribution. So the lowest value, which we're going to give the first ranking to, is the 1, 2, 8, 9. So that's going to be number 1. The second lowest value is the 129.5, so that's going to be number 2. Make that slightly clearer, shall we? Number 2. Our next closest is the 13463. And then our next one's the 138.7. You see, we're just going through all the data. We're not just doing one list and then the other. We're doing them all. It's all in order. Next one is 1391. And I'll just go through after doing this one. That's the 6th one, and fill the others in quickly. So there we have all the rankings. And our next step, as with any of these ranking tests, is to add them up. So for the T for the new device, we're going to sum up all of the numbers there. So it's 5 plus 3 plus 1 plus 8 plus 2 plus 10. So total is 29, and the total for without the device, when we add the 12, 11, etc., is going to be 49. Now let's just do a quick check on those two. So if we add those two together, we're going to have 18, and the end 678. Now we can do a quick check here, because we know that 1 plus 2 plus 3, etc., up to, what's our top number, is 12. We've got a formula we can use to work that out, and that's n plus 1 over 2. So we can quickly check that 12 times 13 over 2 equals, and that equals 78. So we know we've done our calculations correctly. So let's take those two pieces of data away, those two t values, and start using them. So Tn was 29, T not n was 49. Now, okay, so I've just brought in, so that we can see it, I've just brought in here what table 11 says, and the critical values for the Mann-Whitney test, and it says here that our test statistic is going to be T, and then we've got to take off. Our test statistic is U, and that is the T value down here minus the n for that, n minus 1 for that sample. Now in each sample here we had a sample of 6, so that makes life easy. The first one's going to be 29, then minus 6 times n plus 1 is 7 over 2. So that's 29 minus 21 equals 8. And our second U value for U0, that first one was U for n, is going to be 49 minus, again, 6 times 7 over 2. 49 minus 21 gives us 28. So we've now got two t values, and our test statistic, as it says here, that we're going down to look for the test table. For the table, our test statistic is going to be the lower tail, so our test statistic is going to be lower of those two. It's going to be 8. Okay, so that's got us on to the next step. Now we need to start looking at our critical values. Okay, so now we're going to go on and calculate our critical values. Critical values. We've got table 3 gives the critical values for the Mann-Whitney, for the lower tail, and we've already worked out what our test statistic is. So now we need to go into the table and find the right value. Okay, so earlier in this test we already established that we had a 5% significance level. That's what they gave us in the question. And we established it was a one-tailed test because we were interested only in whether emissions were reducing. And we also know what the values of the samples are because each was 6. So there are 2 tables, but we've got enough information to know at this point that we're looking for the one-tailed test at 5%. We've got 2 samples. It doesn't matter which way round you put them in, but they're going to be your M and N values here, and they're going to be, in our case, 6 and 6. So here's our 6M to N and 6N M, and we're going to come down and we're going to find our value. So there's our critical value, and our critical value is 7. So now we've got all the information that we need to complete the test. So let's draw our line, our test line. And again, we've got a test as our line for our hi-ho line. Again, we've got one of these tests where the lower the value, like in Wilcoxon, there is the possibility that you could have a value, your lower value could be 0, and that would be pretty extreme, because that would mean at one end all of the numbers were high, were in one of the samples, and all the ranks that were low were in the other sample. We got our critical value. Our critical value was 7 in this case. So we now know the extreme end, where you've got a very low value, is less than 7. It's between 0 and 7, so that's going to be our high end of our high end. Ho is going to be the more towards the middle. So once again, we've got a hi-ho line where the extreme values are off to the left. We sorted out our test statistic earlier, so let's just go and pick that up from where we got it earlier. That was 8. So let's mark that on here, and it's to the right of our critical value. Test statistic is to the right. So we're not in the critical region, we're back in the main region, so Ho is going to be accepted. So that's the part of our test conclusion. That's the core decision, isn't it? And now we've got to write our context statement. Okay. And here we're going on. As we know HA has been accepted, we're starting with the there is no significant evidence. Significant evidence that. Then we're off and we're going to lift again. We're going to lift and shift the scripture we had at the top. There's no significant evidence that there is a reduction in the average CO2 emissions for a car fitted with the new device. There's no significant evidence that there is a reduction in the CO2 emissions for cars fitted with the new device. For that, you get, let's go back to the mark score, see what we got. For that, we're going to get 10 marks. 10 marks. Sorry, there's one thing I want just add into the model answer. Up here, you need to write that TS is greater than CV, hence HO accepted. And finally, here's a page which summarises the test for you to write down in your notes and use for later. So thank you for watching. I hope it was useful.